Hello, I wanted to go over the pKa problem that I sent out yesterday just to make sure everybody's clear on how to solve that. And again, to make sure that we're thinking the right way when we see a problem like this in the future. So I've put up on the board the four molecules that we're interested in along with their pKa values. And one of the things that's critical from the problem is that we can only use these molecules and their conjugate bases. We can't add anything else to come up with a reaction. So we're not going to add in water, we're not going to add in sodium hydroxide or things like that. We have to use these molecules and their conjugate bases. So when approaching a problem like this, I think the most important thing to start is to write out what the conjugate bases are. And so we're writing the reaction that corresponds to this Ka value. All right, so let's do that first, and then we can try and figure out the problem. So again, for these molecules, when we're thinking about the equilibrium involved, right, we're just going to donate the most acidic proton, which is the carboxylic acid proton for all of these carboxylic acids. So we're going to have the conjugate bases where we've just removed the proton off the OH. Right? And so again, for all of these, we're going to do the same thing. Right? So when we look at this, we have on the top row, we have all the acids. Right? So up here, these are the acids, and down here, these are the conjugate bases. Right? And so when we're looking to come up with reactions to answer this question, we're going to have these 8 molecules to use and nothing else. Okay? So now when we go to do the problem, the first one says we want a reaction with a KEQ equal to 1. When we think about what that means, KEQ equal to 1, that means the pKa difference has to be equal to 0, because 10 raised to the 0 power is 1. Right? And so that means we're working with these 4 molecules here because they have the same pKa value. So when we're looking at this reaction, we're going to take one of the acids plus the conjugate base for the other molecule. And then that's going to give us the other conjugate base plus the other acid. Right? And so again, we have pKa here equal to 4.2, pKa here equal to 4.2. The pKa difference is 0, so KEQ equals 10 raised to the 0 power, which is 1. Okay? Perfect. All right, so now we're going to do KEQ approximately 10. So we're looking for something here where we have a pKa difference of around 1. And if we look at the potential pKa differences, we're going to have to use one of the 4.2 molecules and one of the 4.9. Right? That's going to give us a difference of 0.7, which is close to 1. Right? And it doesn't matter which of the 4.2 pKa molecules you choose. The most important thing is to make sure that you have the stronger acid in the products and the weaker acid in stronger acid in the reactants, weaker acid in the products, so the reaction goes from reactants to products. So we're going to pick one of the pKa equal to 4.2 molecules. I'll just pick this one. It doesn't matter which one. And that's going to react with the conjugate base of this molecule. Give us our conjugate acid-base pair. And again, the pKa here is 4.9. All right, our difference is 0.7. So the KEQ for this reaction is 10 raised to the 0.7, which is close to 1. So it's going to be close to 10 for the KEQ. All right. And the other thing we can do that I didn't do in the first one, again, we can draw our curved arrows. All right, so we're showing bond forming and bond breaking. Right? And again, we're going to have the electrons from the base make the new bond to hydrogen. Electrons from that bond stay behind to give you the negative charge on the conjugate base. Right? And then the final one, we said we're looking for a KEQ approximately equal to 1,000. So we want a pKa difference that's somewhere around 3. Right? And if you look up here, 4.9 minus 1.9, that gives us our difference of 3. So that's going to be exactly what we want to do. Again, we're going to want to put the stronger acid in the reactants, the weaker acid in the products. Right? So we can draw this one out. So we have pKa over here in the reactants equal to 1.9, pKa in the products equal to 4.9, and our KEQ is going to be 10 to the third, or 1,000, right? And again, we're always going towards the side with the weaker acid, right? From stronger acid to weaker acid. So again, I hope it's clear that when you're given a problem like this, when you're thinking about pKa, don't forget to write out what you're actually doing in terms of the acid going to the conjugate base. All right, that was something we struggled with a little bit on the quiz, making sure we were looking at the correct acid conjugate base pair. All right, so make sure you do that when you're doing problems like this. And again, when a problem is set up this way, you can't add anything extra. You have to use only the molecules given. All right.